Good morning, gold day classes. Hope you're having a great day. I won't talk too much here at the start, but Mr. T's gone. Hope you have a great Friday. I'll see you next week. And here we go. I got a little lesson for you, so plug in, check it out. If I'm going too fast, pause it, take you some notes, and then keep watching. I'm going to try to keep this not super long, but it's an important lesson, and we're all excited. I know. All right. So here we go. We have 8.6 is the last new material before we have a review day. We might have two review days because I might want to review this stuff with you individually, but I haven't decided that yet. So we'll see. This is the law of sines and cosines. This is some crazy, cool, powerful stuff. Okay. So here's a little intro to it. Here's the idea. Okay. Basically this whole chapter, I don't know why it just says last two lessons. Basically this whole chapter, we have only used trig on right triangles, right? We did Pythagorean theorem right triangles, we did special right triangles, we did trig, we did our little thing outside. That all had to be a right triangle, okay? Now, right triangles show up a lot in things, and that's why all that trig is really cool and powerful, but they're not always right triangles, okay? So the law of sines and cosines allow us to do some trig with non-right triangles, okay? Super cool, super cool. So let's jump into it. We're going to start with the law of cosines. This looks really scary. It's not that bad, okay? It's not that bad. So here's the law of cosines, okay? The law of cosine says if triangle ABC has lengths A lowercase ABC, and then the angles are represented by big ABC, here are the law of cosines. Now, you don't need to write all three of these down, but write one of them at least. But the idea is, if you notice, okay, we're going to either be solving for little a, like let's look at the first one. We're either going to be solving for little a or big A, okay? And you're always going to put what you want either in that A spot and then the side across from it. I know that doesn't make a lot of sense right now, but it will in a second. Basically, this is saying it works for any angle that you want to solve for or any side. You just have to know how to set it up. So write one of these down. If I'm going too fast, pause it and write this down, and then we will go through it. So we want to use the law of cosines to solve a triangle if we know two sides in an angle or if we know all three sides, okay? So we need to have either side angle side to use this law of cosines, or we need to have side, 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 okay? Otherwise, we can't use this one. All right, and I'll show you an example of each one. So again, I would definitely make sure you write this down, that's how, when we can use it. All right, let's do an example here. Okay, we're going to use our little formula. Okay, so we want to solve for, sorry, hold on, I'm trying to get my pen here. We want to solve for x squared, right? So that is the side we're going to put by itself, okay? That is the side we're going to put by itself. So it's going to be x squared, this is a weird little box, equals, okay? Put that side by itself, then you square the other two sides. 9 squared plus 11 squared. I'm going to run out of room. Ah, the stupid box. Hold on, let me rewrite this. Let me rewrite this. I'm sorry. Stupid little box there. So we're going to get x squared equals 9 squared plus 11 squared minus 2, that's just the formula, times 9 times 11. So you see how those sides we didn't solve for repeat? Times cosine of the angle across from the side that we want. which is 28. Okay? That is how you set it up. Okay? I'm going to double check. I think I got that right because I'm smart, but I'm just double checking. Yeah. Okay, so there we go. So I set it up the right way. So put the side that you want by itself. And then it's gonna always, you're gonna use the angle across from that side, and then you square the other two sides and then do -2 times those other two sides. The hardest part is setting it up. Now it's just math. Now you guys know how to do math. It's algebra now, okay? So now let's keep going. And we're gonna get x squared. Man, I might have to get out a calculator. I can do these ones. Equals 81 plus 121 minus, actually, I might need a calculator for this. Hold on. Okay, 2 times 9 times 11, so 18 times 11. Okay, so hold on. Let me talk you through this. So we get 198 times the cosine of 28. Now here's a mistake I see all the time, kiddos. These are still being multiplied. Remember, cosine of 28 is a number. So many people will add these two and then subtract the 198. Do not do that. It's being multiplied. You cannot do that, okay? So it's going to be 81 plus 121 gives us 202. So we get x squared equals 202 minus 198 times cosine of 28. Again, do not subtract. You may not subtract. Unacceptable. Okay? You got to multiply by cosine of 28 first. See that mistake constantly. So it's 198 times cosine of 28. Should probably make sure this is in radians. Someone else was using this. So we get 174.8, and then we're going to do 202 minus 174.8. Okay, and we get x squared equals 27.17 something. Okay, but just keep the answer in your calculator, and then we're going to take the square root of both sides, right? Because we got x squared. So we're going to take the square root, and just in your calculator, do second answer, right? Don't just round it. Do second answer so you get the whole decimal square rooted. And we get x equals to 5.21. Okay? That kind of makes sense. This is probably the smallest aside because it's across from 28 degrees. Okay? So that probably makes sense. It's smaller than 9/11. Okay? Let's double check. We got the right thing. We did. We did. They took the square root a little earlier, but you can just wait and take it at the end. So that's our first example law of, sorry, I'm gonna sneeze. Gosh darn allergies. Sorry about that. All right, we're back in it. All right. Anyways, that is it. Well, that's our first example. Now we're gonna do another example where we have two sides. Remember, we had two ways we could do it. Side angle side and side side side. We did the side angle side version here, right? Let's do a side 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 version. See how we're feeling. All right. God, why don't I have any room on these? You're gonna see some weird words there, but I need more room. Ignore those blue words. Okay. Same idea, but now we're solving for an angle and we have all the sides. But again, it's the same idea, okay? We put the side that is across from the angle that we want by itself, okay? So 8 goes by itself. Let's change colors. So we're going to get 8 squared. We're picking 8 squared by itself because it's across from the x. So we get 8 squared equals 3 squared plus 6 squared minus 2 times 3 times 6 times the cosine of x. Now you notice our variable's in a different place, right? Let's see what's better. Can you read that? Okay. So our variable's inside the cosine. So what are we going to have to do at the end? Inverse cosine. Yeah. Who got that? Someone got that in the back. Nice. Good work. All right. So we're going to have to inverse cosine. But again, the setup is the hardest part. Just remembering all this, because guess what? You got to memorize it. But now we just got to do math. Okay. So we get 64 equals 9 plus 36 minus, and again, you've got to be super careful here. We cannot subtract. We cannot subtract at the moment. Minus 2 times 3 is 6. So 6 times 6 is also 36. Cosine of x. You may not subtract that 36. It is still being multiplied towards the cosine here. Okay, so we got to add these. We get 64 equals 45 minus 36 cosine of x. Again, you may not subtract there, kiddos. You may not subtract. All right. Again, you can't subtract that 36. We got to subtract the 45 first. So we're going to subtract the 45 from both sides. Okay, what does that give us? 19? Double check that. That's right, though. So we get 19 equals negative 36 times the cosine. Keep that negative there. That does not disappear. Times the cosine of x. So what do we do now? Houston, what do you got? We divide? Yeah. We divide by negative 36. Houston got that one. Good job. Okay, so we divide by negative 36 and we get 19 divided by, because these are being multiplied. So we got to undo the multiplication. We get 19 divided by negative 36 equals cosine of x. Okay. Beautiful. Now we can undo the cosine with inverse cosine. So we get x equals the inverse cosine. We take the inverse cosine of both sides. 19 divided by negative 36. And that's what you're going to put in the old calculadora. Okay, let's see what we get. Inverse cosine. Remember, you got to go second cosine, 19 divided by, make sure you put a negative with 36. And we get x equals 121.86 degrees. Remember, we're finding an angle here. Okay, which makes sense again. Look at our triangle. It's a nice obtuse angle. 8's definitely the biggest side. So we get x is 121.86. Now I realize I'm not here and this could be a little tricky to do on your own, but the cosine one is harder. Yeah, look, they rounded, but we got the same thing. And if you are still confused, maybe go back. If you're trying your homework, go back and rewatch me go through a couple of these. But getting them set up is the hardest part. And then you just have to solve. Okay? Just solve. And again, this one might be a little tricky too, but cosine was the harder one. Start with the harder one. Okay? Good talk. Let's go and do sine. Okay? Here is the law of sines. Okay? Now, you see it is a ratio here. We get this nice ratio. The sine of angle A over side A is equal to the sine of B over side B is equal to the sine of C over side C. Okay? We are only going to use 2 of these at a time, but depending on what sides we have. So we're either going to do sine of A and sine of B, or sine of A and sine of C, or B and C. Okay? So you're not going to do all 3 at once. You're just going to do 2 of them depending on what you need and what you want. okay? Again, we're going to use the law of sines if we have angle, angle, side, or angle, side, angle. So remember, we did law of cosines when we had 2 sets of sides, minimum, or 3 sides. Now we're going to do it when we have 2 angles for the law of sines. All right. Let's do it. Let's move this a little bit. Again, I need some more room. Just ignore the blue lettering. Okay, so you're going to do the sine of the angle, right? So we're going to do sine of 21. These ones so much easier. Sine of 21 over the opposite side, okay? Opposite of sine is x. And then we're going to set it equal to, and again, remember, we're just doing one proportion, basically. Sine of 97 over 16. That is it. That's the setup, okay? That's the setup. Just like that, okay? Sine of 21 over the opposite side, x. Sine of 97 over the opposite side, 16. We set it up beautifully. How do we solve a proportion? That's all we did in chapter, what was that? Sorry, allergies are killing me. Chapter 7, that's all we did. We cross multiply. So we get 16 times the sine of 21, okay, equals, whoa, sorry. That's a 1. Looks terrible. Redo. Who said cross multiply too? Sounded like Gemma. I think Gemma called that one out. Nice. And then we get x times the sine of 97. Okay, now we just got to solve for x. We divide both sides by the sine of 97, and we get x is equal to 16 times the sine of 21 over the sine of 97. That's it. You're going to put that in your calculator. See what you get. Let's see. 16 times sine of 21 divided by sine of 97. I got 5.78. And again, that makes sense. Look, we were trying to find a side that's across from a small angle. So 5.78 is definitely smaller than 16. That's it. Isn't that cool, folks? Isn't that super cool? Let's make sure we got the right thing. We did. Okay, nothing crazy there. Now, this was an angle side example. So we're going to do one more example. And I think we're calling it. You should know how to do it. Might have to rewatch some of this if you're feeling a little lost in translation, but that's all right. I'm going to be back next week. We can practice more. Let's do one more example. Okay, now we got an angle side angle. Okay, angle side angle. And they're trying to trip us up a little bit. Okay, do you see that? And they're telling you right here what we need to do. There is nothing across from the 73. Okay, there is nothing across from the 73. So we don't want to use it. We're trying to find this x, and we need to use the 10. So we need to find this angle here, K. We need to find, let's try a different color. Ugh, what gross color is that? Maroon? What are they doing to us? Okay, we need to find K. All right, so you know how to do it. We've done triangles all year, and you can see what they did up here. We're just going to do 180 minus 45 minus 73, and we get 62. Now we're in business, kids. Now we're in business. So sometimes you might need to find another angle. And now we're good. We're going to use 62 and 10 and 45 and x. Okay, so sometimes you might need to just find the third angle. It's not a big deal. I'm going to slide this and then ignore those words, and let's start the problem. So we're going to do sine of 62 over 10 equals sine of 45. We don't want to use that 73 because there's nothing across from it. Sine of 45 over x. X is what we want, so make sure you get your x in the problem. Okay, and again, proportion, cross multiply. We get x times the sine of 62 equals 10 times the sine of 45. Okay, and now just solve for x. It's being multiplied by the sine of 62. Sine of 62 is just a number, so we divide by it. And we get x equals 10 times the sine of 45 divided by sine of 62. And that's going to give us a number. Comes out to 8 approximately. It might be a different thing, who knows. We get x equals 8 according to the Libro. Good old book. And this is side length, right? So there we have it. I gave you 4 examples. I think we did like 20 minutes there, so I don't want to keep you too much longer because hopefully you were pausing and taking notes, and so this probably took you longer than 20 minutes. But you're gonna have some homework ones. Practice. If you want to work with a partner, I think that's a good idea. But practice this. If you need to go back to the video to see how I did it, that's good. Or if you want to look in your book and look at how the book did a couple examples, you can do that as well. But you got this. You got this. Best of luck. Hope you have a great weekend. We will talk to you later.